Hey guys, welcome back to part 2 of quadratic inequalities. Yesterday we talked about how we can graph these to show the solutions. We wrote things in vertex form, we graphed it, we found the y-intercept, talked about solid or dotted lines, and then we talked about what happens when there's no y involved, kind of like this, and we're just looking at just the x-axis, what x values make that guy true. And today I just want to do 2 examples left just to kind of wrap it up. This example here, I'm going to show you what happens when the values don't come out nicely, okay, because that can happen. And the last example will be like a word problem and how can we interpret a quadratic inequality through some context involved, okay? So let's go ahead and get started. Up here I have a quadratic inequality we're trying to solve for, and I want to figure out what x values make this guy greater than or equal to 0. That means I got to solve, right? I got to come up with some sort of solutions, which will give me like a boundary, right? That's where I cross the x-axis. And I'm going to test some points to see if it's going to be, the solution is going to be in between the 2 roots or if they're going to be outside of it, okay? Now, to solve this, which, I was missing my red marker. To solve this, we have a lot of different ways of doing it. We could factor, complete the square quadratic formula, or do like an XY table, which isn't good if the values are, well, irrational, or if they're not whole numbers. That's going to be a little bit of a problem. I'm going to say no for this guy right now. So for factoring, could we factor this guy? Well, if I was to factor this, we'd what? -2 times 1, we -2, factors of -2, that gives me -6. Doesn't work out. Not a good way. So factoring and table, nope. Complete the square quadratic formula, we could do. And it works no matter what the quadratic is. I think we're going to have to do that, right? Do you have a preference? What do you think? What's your preference? You want to complete the square or do a quadratic formula? Okay, complete the square. Sounds like a good idea. Let's try that out. Okay. Now, this inequality symbol, I'm going to ignore it temporarily. I'm going to need it for the very end of the problem. I'm going to just write it as 0 equals -2x squared minus 6x plus 1. The goal is, what are the solutions? That's all I care about currently. What I'm going to do is group these guys together, okay? So the -2x squared minus 6x are going to be its own little group. Plus 1 just kind of goes out the outer part of it. I'm going to factor a -2 out. I'm left with x squared plus a 3x. Just like that. And once again, we did videos on complete the square, so I'm not going to go through every single thing. Excuse me, I got the hiccups. I'm just so nervous filming. But I'm not going to go through every single process and why we're doing it. Okay? So watch those videos to kind of see what we're doing. Now I want to make this guy a perfect square trinomial, so what number do I plug into here that makes it work? Well, you take half of this guy and square it, and you get 2.25. Now, notice, usually I do a fraction, but in this case I'm not, and the reason for that is because I need actual solutions, not fractions at this point. Now, I could simplify the fractions at the end and get those answers, but why not just skip that step, right? Now I'm going to go ahead and factor out the perfect square. Remember, the factors are just half your b value. That becomes x plus 1.5. Now, I have an issue. Because I added something to this equation, I'm no longer the original quadratic no more. It's gone. So to balance it out, I have to subtract. And remember, this isn't really 2.25. It's -2 times this guy. So that gives me, what, 4.5? It would be a -4.5, I should say. Okay, and we're going to subtract it. Boom, boom. Okay? That will make sure that when I combine these guys, I get the original. Down here, it'd be, let's change it now. If I'm subtracting it, it'd be 1 plus 4.5, so this would be a 5.5. This is in vertex form. I could graph this, but that's not what the problem really wants. I know we're kind of solving by graphing. We're getting to that point, but I don't need the vertex form. I got to still solve for x. Add 5.5 to the other side. Just like that. Divide both sides by -2. I get 2.75 on this side, and then x plus 1.5 quantity squared, okay? Take the square root. Now what I'm going to do, because I want to type this in the calculator, makes it easier for me, I'm going to leave it as square root of 2.75. My calculator is going to hold all those values. On this side, I get x plus 1.5 equals positive negative the square root of 2.75. Okay, we're still going to indicate that there's two solutions to this square root. Last step, I'll bring it up to here. We have x. I'm going to flip it to the other side. Don't get confused by that. X is going to be equal to negative 1.5 plus or minus the square root of 2.75. Those are going to be my solutions. Okay, I'm going to take the negative 1.5, add the square root of 2.75, then recalculate it, except the second time I'm going to subtract it. Okay? To save some time, the first value is going to be negative 3.16 hundredths. The second value is going to be, it would come out to be 16 hundredths. Okay? Those are going to be my two solutions to this guy. I'm out of space. Just going to push this over. Okay, there. All right. Now, what am I going to do with those solutions? Well, remember, I don't have to graph the entire xy plane. I only focus on x values. Sorry. There. But if you want to still graph it, you can. But still, we're here at 0.16. Oh, is it negative? It is negative. Okay, good. Sorry, I got to graph it a little bit differently here. You know what? I changed my mind. We're just going to do a number line. There we go. Okay, we're just going to do a complete number line. We're not going to worry about that right now. Okay. Now, real quick. Yeah, I think we're good on this. Just want to make sure my calculator's reading this correctly. Now, I got to figure out, are all my answers between here or outside? Now, notice there is an equal to sign. Whatever makes this 0, I want to include. Therefore, I'm going to put closed circles there. That just is, it's a symbol indicating that, hey, those are answers to it. Okay, let's test a point, and why not test 0? Right? If I could use 0, why not? Plug 0 into it, so 0 less than or equal to negative 2 times 0 squared minus 6 times 0 plus 1. Simplify, I get 0 is less than or equal to 1. That is a true statement. Therefore, all of these answers between my two roots satisfy this inequality. Could you test a point outside of here and see if it doesn't work? Absolutely, and I encourage you to pause the video and do that. So that way you can see that only answers in between these two roots are going to work. And what we could do is just write this all together. All my x values, such that x has to be between negative 3.16 and 0.16. We could write it a little bit more formally as to where all my answers are. Or visually would be something like this. Because we rounded, it would behoove us to actually keep it like this. That's more of an exact answer, but because we're trying to figure out more precisely round about where these answers are, we rounded it. All right. One problem that's kind of messy, but not too bad, but I wanted to show you an example where the numbers don't always come out to be whole values. Okay. Next one is a word problem. So let's go ahead and talk about this. And boom, new whiteboard. Instant whiteboard. There it is. Okay. Last example. I'm going to read this to you. It's story time, guys. Gather up around the fire. The height of a ball above the ground after it's thrown upwards at 40 feet per second can be modeled by this function. Okay? Where h of x is given in feet and time, which is x, is given in seconds. At what time in its flight is the ball within 15 feet of the ground? Now, let's think about this for a second. If I were just to draw, generally, I I have a baseball, or just some ball. It's being tossed in the air, okay? And within this space, that ball is within 15 feet above ground, right? Okay, so 1, 2, 3, 4 feet, all the way to 15 feet. That's the area that I'm looking at. If I go past right here, if I go past that point, the ball's on the ground rolling, okay? If I go previous to this point, well, the ball hasn't even been thrown yet, okay? My answers, therefore, have to be between those two roots, those two solutions. What I'm going to do is solve this quadratic for those two solutions, and then that's going to tell me what times will keep the ball within 15 feet in the air. X is my time, which is in seconds, okay? And h of x, they told me, was your height, and that's in feet. The one critical detail, don't go solving this yet, don't you dare, put the pencil down, we're not done yet. This has to be within 15 feet, this parabola, the part that we're looking at. Therefore, I could say that my inequality is this parabola, okay, where is this parabola less than or equal to 15? Okay, which is between this area, right? Solve this, and I'm going to rearrange this. Negative 16x squared plus 40x minus 15 is now less than or equal to 0. Okay, that's what I want here. Does that make sense, looking at this? Okay, because I want it to be within 15 feet. That's critical. Now what I'm going to do is solve this for the roots, and now tell me the range as to where the ball is in the air. Okay, sound like a plan? Solving this, factoring, we could maybe factor, but I'm going to be honest with you guys, I don't think this is going to factor nicely. In fact, it might not be factorable at all. Completing the square, we could do that, but that might get a little ugly. The one option that's coming to my mind would be quadratic formula. A little bit more precise, a little bit more steps than needed, but it's still precise enough for it. So here's the quadratic formula. Remember, the inequality symbol, I'm not going to worry about to the very end, just like the previous problem. Plug in my values in. We need A, B, and C. A is always in front of the quadratic term. That's negative 16. B is the linear term, which is 40. C is the constant, so that's negative 15. I'm going to plug those values into here. I get negative 40 plus or minus the square root of 40 squared minus, 4 times my A value times my C value divided by 2 times my A value. Okay? Simplify. 40 squared minus, there's 3 negative signs here. That means my answer is going to be negative because there's an odd number. It's going to end up being 640 when I subtract those 2 underneath there. Divided by negative 32. Okay? Now, what I'm going to do is I'm going to plug this in a calculator and see what the answers are going to be. So I'll do negative 40 plus the square root of 640 divided by negative 32, and then negative 40 minus the square root of 640 divided by negative 32. Okay? And I'm going to get 2 x values. Let's see what they're going to be. I don't know why I'm singing Christmas carols. It's March. I got no clue why. One of the answers will be, round of applause, here we go, 46 hundredths. The other one would be 2 and 4 hundredths, okay? Those are going to be my 2 answers. Going back up to my quadratic here, that means at this initial point, we're at 0.046 seconds. At this initial point, we're at 2 and 4 hundredths of a second, okay? So between that range of values, the ball is in the air, okay? Now, I know what you're probably thinking. Isn't this on the ground? Okay? We're assuming that the person that is throwing it, we're kind of just like I said, making the assumption that that's 0, okay, for us. And then we're going to throw it in the air, and it's going to land. Now, technically, we probably should say that this would be at the same length, at the same distance as the person holding the actual baseball itself, or ball, whatever it is. But we're kind of neglecting some other details just to kind of get the idea of what's happening. Okay, so for those of you questioning some things, I get it. I honestly do. But we're just going to keep it simple for right now. Okay? We're going to, just for once, we're going to just say physics is going to support this. All right? Which I don't like doing, but for right now. Therefore, I can write my answer. All x values between these two values. I just have enough space for that. Okay? And that's it. So technically, this will actually be a little bit past 2 400ths when it actually hits the ground. But like I said, we're just assuming some things and we're going to keep it as is. That's it, guys. Okay? Hopefully that helps. Gives you 2 examples. One that's a word problem, one where the numbers didn't work out so nicely. Okay? Look at my notes. I have other examples in there so you can take a look at it. But other than that, that's it. Quadratics, all done. Hope you guys are doing well. Until next time, I will see you in the next lesson video. Take care.